Hello students, welcome back again to another video tutorial on data structure, and today I'm going to talk about insertion sort technique. Insertion sort is one of the many sorting algorithms that is very interesting. In this video I'm going to show you how insertion sort technique works and how we can implement it in C++. So let's jump right into it and get started. Already we have learned two sorting techniques, that is bubble and selection sort technique. The third sorting algorithm we are going to talk about, insertion sort. The good way to understand this is to think of playing a card game. So imagine each item in the array represents a card. The deals we give you one item or one card at a time. Every time you got a card, it's inserted at its right position. Here, these are 5 items or 5 cards you got. So first you get 8. Keep it. Then you get 2. You insert it before 8. Next you get 4. Insert it in between 8 and 2. And then you get 1. You insert it before all the items. Finally you get 3. You insert it after 2. So every time you get an item, you insert it at its correct position. And that is why it is called insertion sort technique. Okay. So why it is called insertion sort technique? Because every time you get an item, you insert it at its correct position. So that is why it is called insertion sort technique. Now let's see it is in action. So we get 8, we should find its correct position amongst the item or cards we have taken so far. So 8 is the only item or only card we have seen. So we assume that it is in the correct position. So next item for you is 2. We should insert it before 8. But how? Unlike the previous algorithm, that is bubble and selection sort, we are not going to swap here. Instead, we are going to look at all the items we have found so far. If they are greater than 2, we should shift them to the right. That means we have to shift 8 to the right to open space to insert 2. So this is the key distinction between insertion sort and other sorting techniques we have talked about. Instead of swapping items, we shift them to the right. We'll see why it is in a second. So 8 is greater than 2 and we should shift it to the right to open space for 2. To do this, first we store 2 in a temporary variable called temp. We'll call this as a current variable. Next we shift 8 to the right, or more accurately we copy it to the right. So it overrides 2. That's why we have to store 2 in a separate variable so that we don't lose it. Now technically we have stored 8 in 2 places in this array, but conceptually we can assume that we shifted 8 to the right. Now the item in index 0. Now the item in the index 0 is empty. So we store the value of this current to 2 in this index. Okay, so we inserted 2 in the correct position amongst the items we have seen so far. This is the sorted part and this is the unsorted part. This is the unsorted part and this is the sorted part of the array. In every step we picked one item from here and insert it at correct position in the sorted part. So next we get 4. Next we get 4. Now we look at the item we have seen so far, if they are greater than 4 or not. If they are greater than 4, we have to shift them to the right to open space to insert 4. So here we shift 8 to the right. Now what about 2? What about 2? Should it be shifted right? No, because 2 is smaller than 4. Yes, 2 is smaller than 4. It should stay where it is. Now we found 4 is 4 in its right place. All the items we have seen so far are at correct position. So next is 1. Again, we should shift all the greater items to the right to open space for 1. Here we should shift 8, 4 and 2 to the right because they are all greater than 1. Now we insert 1 at its correct position. We are almost done. One more time. That is 3 is only remaining. Now 3. For 3, shift all the larger item, then 3 to the right, and now we insert 3 at its correct position. Now we can see that the array is fully sorted. Here you can see this array is fully sorted. So that's all about insertion sort. This is the insertion sort technique, how it is worked. We have seen with this example, that is with this array that contains only 5 elements. So I think now you can understand something about insertion sort, how it works. So now I will try to write the code for this insertion sort technique. So let's get started. Okay, so as you can see in the screen, I have already opened up my C++ terminal and typed a little bit of C++ code for the insertion sort technique. And what I am going to do is I will drop the algorithm in the right side of the screen. Just we need to convert this algorithm to its proper code. So in C++, we know that the execution starts from the main function. That means in main function, program starts and ends. So here what we will do, we declare an integer or int myArray. So the name of the array is myArray. So let's keep the size of this array is 5. So to input from the user, we need a for loop. Okay, so before that I will say cout under the 5 elements. So for I will 0 to 5 I++. So cin I. Okay. So next I will write the code for this sorting in a separate function, that is user defined function, that is insertion sort, and I will pass this array to this function. So I will call this function, that is insertion sort, within bracket the name of the array, that is my array. So I will pass this array to a separate function called insertion sort, and the insertion sort process will take place in this function. Okay, so we have inserted the 5 elements. Now I want to display these 5 elements before sorting. So write cout before sorting the elements are. So for loop, and then here should be cout myArray. That means I want to show the elements before sorting and then after sorting also I want to show the elements. Since we have, so after sorting the elements are these. And I have created this separate function for sorting. So let's see if the printing is happening or not. So we have not written the sorting function till now. So let's see whether this printing is happening or not. Okay. So let's enter 5 integers. Say these are 4, 3, 5, 6 and 1. So if I press enter, then before sorting the elements are 4, 3, 5, 6, 1. And after sorting also 4, 3, 5, 6, 1, because I have not written the sorting function till now. Okay. So here I should write endl. So I will correct this. So here endl, if I write endl, then the output screen will be looks better. So now I will write here the sorting technique. So what we have get a parameter here, that is a double r, that is an array, that is this array is passed from this insertion sort and we receive that array here. So what is this? So when you pass an array in C++, in any function, it is passed as address. Okay, so it is not passed by value. I hope you know that what is passed by value, what is passed by reference, what is passed by address. So when you pass my array inside this function, insertion sort function, this ARR, which is passed over here, basically a pointer to the same array, and so a double r basically pointing to the base address of this my array. Okay. So now we will write the code for this function. So declare variables I, j and key, int, j and int k. You can write in single statement also. Then I need to write a for loop for 1, 2 and -1. So I will explain all this after writing. So what we have written, so first the key, in the key variable, the first element of the array is picked up and we have stored the first element in the variable key, and j is equal to I-1. So in this while loop we have to say whether j is greater than 0 or not. This j always should be greater than 0 or equal to 0, but it should not be less than 0. And what is this? We have to say whether the array elements is greater than key element. If the array elements is greater than key element, then what we have to do? We have to shift. We have to shift the elements, and then we have to place the key element in its correct position. So here if you can see, if the key element is 4, if we assume that the key element is 4, then what happens? 5 and 6 should be shifted to right, and it is done with these two statements, and the condition is checked within this while loop. Since 4 is less than 4 is key and 4 is less than these two elements, so they are shifted to the right and 4 should be placed in this place. So we have to write what ARRJ plus 1 is equal to key. Key element will be placed here. So I think the program is complete. So yes, so I will run this program. So if we run this program, so enter the 5 elements, so 5 integers, say 4, 3, 6, 7, 1, and if I press enter, then you can see before sorting the elements are these, and after sorting these are the elements. So how it is done? So first what we have done, we have picked, we get 4, so we have keep it, and then we get this 3. So since 3 is less than 4, we have to insert this 3 before 4. Next we get 6. Since 6 is not less than this, so what we have to do, we have to keep this element, that is keep this key element 6 in its own place. No need to write in another place, so it will be in its own place. So next we get 7, since it is also greater than this element, so it will be here. Next we get 1, again 1 should be before all these elements, so all the elements should be shifted to the right, and shifting is done with these statements, and then 1 is written in this place. So that's how the program is written. So I want to request you to take a small example and compare these statements with that example and try to understand this code with an example only. Then only you can understand this code. This is very interesting. So that's all for today. Have a great day.